Here are top 10 SQL questions that you might be asked during your job interview. Hi, my name is Eugene and I'm a data engineer with over 5 years of experience in the industry. And during these 5 years, I have been to the both sides of the interviewing process. I have been there as a candidate and as one of the interviewers. So for this video, I have reflected on these experiences and also have done some additional research to come up with a comprehensive list of top 10 SQL questions that you might encounter during your interviewing process. So without further ado, let's dive into the questions. So here is the first and probably one of the simplest questions that you will encounter. But before we start talking about it, I want to make a quick remark about the format of this video. So basically we will go through all of the 10 questions. We will also execute some examples so that you can have a clear understanding of what's happening, because in my humble opinion, I think that's the best way to understand something. But I will not go super deep into each one of them, because if I did, it would be too long of a video. So I encourage you to read separately upon each topic that you struggle with to get deeper understanding. The first question, which join types exist and what are the differences between them? And it's a fairly simple question. You just need to read about them once and try each one of these joins. Yeah, and they're pretty straightforward, so we'll quickly cover them. So the first join type is inner join, and it's one of the most widely used join types. And it works like this. We take two tables and join them based on a certain key. And as a result, we get only matching rows from both tables. Another type is left join. So basically, we take all rows present in the left table and only the matching rows from the right table. For those rows that are present in left table but did not find a match in the right table, the columns from the right table will get null values. The right join works in the same way as a left join, but we take all rows from the right table and only matching rows from the left table. Next type is full outer join, and here we get all rows from both tables. And for the rows that are, for example, present in left table but missing in the right table, for the columns coming from the right table, we will get null values. Another join type that is not actually widely used, but it's good to know about it, and there are some use cases when it will come in handy. The cross join, basically it works as a Cartesian product, and which means, for example, for each row in table A, we will match it against all rows in table B, and it will result in a huge table, because for each row from one table we'll get all rows from the other table. So you can see how huge the table will be after we perform this type of join. Another join is semi-join. For this join type, we get only rows from left table that have a match in the right table. And the fair question here to ask is, how is it different to the inner join? I'll try to answer this question with a quick and simple example. Let's say we have two tables, products and reviews. In products table, we have product ID and product name. In reviews, we have review ID, product ID to match it with the product, and some other review fields. And let's say we do an inner join here. And if we have a product with ID 1 that has two reviews and we perform inner join on it, in the resulting table we will have two rows for this product, because one row from products table matches two rows from reviews table, and as a result we get two rows here. But if we do a semi-join here, we will still get only one row from the products table. So basically the goal of semi-join is to just perform a filtering. For example, to get only products that have at least one review. And when we do semi-join, we are not interested in the columns in the left table, but we just want to get rows from left table that have a match in the right table. And the final join type that I'll mention is anti-join, and this one is just an opposite of semi-join. Basically, we will get rows from the left table that do not have a match in the right table. Great, so moving on to question number 2. What is the difference between where and having clauses? Extremely popular question. I have asked it myself and I have been asked it a lot of times. And here is a quick answer. Where filters rows before grouping and having filters rows after group by. And for this one I have a quick example for you. Let's say we have such table. We have salesperson, we have region, and the amount of something that this person sold for. Let's say it's the amount of cash they brought to the company. And here we have a query with the where clause based on this sales table. And we want to have sales that have an amount more than 1,000. So the key thing here is that the rows are filtered before we do the aggregation, before we do the grouping. And as you can see, we have such a result here. So basically what it did, it first went through the source table and filtered out the rows that are below 1,000. So for example, this row was filtered out for the region south. So for south we only want to see 2,000, and that's what we see. And if I comment it out, and let's try to run it with a having clause, and having on the other hand will do the filtering on the grouping result. So first it grouped it by region, then calculated the sum of amounts for each region, and only then it applied the filtering. So as you can see, we have only 2 regions here, and East is not present because for East we have only one row with amount 1,200, which means it fails this having condition. Essentially, you can think of having as just a syntactic sugar that saves us one extra query that would be like this, based on the result of this grouping, and here we would do where clause, and it would give us the same result. And it's time for the question number 3. What is a primary key and what is a foreign key? It's not precisely a SQL question, but it's a more general database question, but I'm sure you will be asked it, and it will be asked in the same SQL section, SQL part of the interview. So just a quick answer to this question. So primary key uniquely identifies a record in a table. This is its primary goal. And 2 features that you should remember, that it cannot have duplicates, because otherwise it wouldn't be able to uniquely identify the row in the table. And it cannot be nullable for the same reason. Another feature that I have just remembered is composite primary key. And basically it means that we can have a primary key based on 2 columns. So values from 2 or more columns will uniquely identify the row. It's not very common, but it's still possible, and you might encounter it, and you might get asked this question. And the goal of the foreign key is to create this relationship between one table and another table by referencing a primary key from table A in table B, which creates this referential integrity, basically this connection between 2 tables. Question number 4. Purpose of indexes and types of indexes. In this topic you can go very deep, but here are just a few key points about it. The purpose of the index is to speed up data retrieval process. If you have a huge table and you notice that select queries with a certain filtering condition happen often on this table and they take long time to give you the results, it might be a good sign that you should consider creating an index if this column that participates in the filtering does not have an index yet. And here are the types of the indexes that we have. So I would say there are two main types. The first type is a clustered index, and it sorts the actual data rows in the table. So it physically sorts data in the table, and this is the reason that there can be only one clustered index on the table. Usually it's a primary key, but yeah. So clustered index physically sorts the data, and there can be only one clustered index on the table. Non-clustered index, basically it's a data structure of pointers to the physical locations of rows in the table. It doesn't physically sort the data, and it means that we can have many clustered indexes on the table. In most databases, it's a B+3 data structure that is used for this quick search of the rows, but there are actually many more data structures used for indexes. B+3 is just the most common one, and yeah, the most widely used one. So unique index, the main goal of this index is just to ensure that all values are unique. Pretty simple. A composite index is a feature of index that an index can be built on several columns. So basically not just on one column, but on two or more. And question number 5. What is the difference between delete, truncate, and drop? Delete operation removes rows from the table only with a condition. So basically, if you try to execute query like delete everything from table A, it will throw you an error and say that you must use a where clause to filter rows that you want to be deleted. You can still trick it like delete everything from table A where 1 is more than 0. So with this dummy condition, it will still clear all the table. Another feature of delete is that it's almost always can be rolled back because it's a part of data manipulation language. Another command that is often used instead of delete is truncate, and truncate removes all rows from the table. It's faster than delete. It works without the filter, and it's a part of the data definition language. So here we will not use truncate for the cases like where we want to delete rows, for example, where salary of employee is more than 2000. Essentially with truncate we wipe everything from the table, but we want this table to still exist so that, for example, we'll write new data in this table. And generally you can't perform a rollback after you did a truncate. You can still restore data in modern databases, but using like another technology that temporarily stores the data even after you delete it using time travel window. But overall, it's like a different topic. Let's move on. The last command is drop, and drop just drops the entire table, the structure and the data. So if you want to remove completely the table and the data, we just can use drop table. If you're interested in more content like this, please subscribe to the channel. I would be very thrilled to have you here. With that, thanks for watching, see you in the next one, and happy coding.